Overall, what we see is some improvement in Human Development Index, rising to 0.619 in recent time. Despite such a big progress, what we see considerable problem. We still have 1/4 of world's hungry, 40% of world's malnourished children and women. We lag behind in meeting most of the Millennium Development Goals. And a relatively recent survey indicates that given a choice, 40% farmers would like to leave farming. So it's relatively becoming unremunerative. Now, climate change, what is being discussed now, will further compound the situation. Now, quickly looking at the situation here for India, if we look at these temperature scenarios, what we see, especially in the Gangetic Plain, we see a significant rise in temperature. That's what most model indicates. In terms of precipitation, things are not very clear, as was also indicated by previous speakers. But overall, what we see is relatively small increase in precipitation in absolute terms in time to come, about 10 to 15% in several areas of India. Now, given this scenario of climate change, what we really need to do is first to understand what are the vulnerabilities, what are the impacts, likely impacts agriculture will face due to this type of climate change. So what we have been doing in India is establishing facilities for climate change studies, free air carbon dioxide enrichment rings, several open-top chambers, temperature tunnels, and a variety of field experiments coupled with simulation models we have been using to understand the impacts. I'll quickly run down through many of these slides which show impacts on specific crops. For example, this is wheat, 2050 mean of several scenarios, and what we see areas here in central India will get significantly affected. Similar is the case with maize, several areas which will be affected, but at the same time we see several new areas will see some benefit, and that's largely at this stage because we have not really considered climatic extremes. Once we start considering droughts and floods, I think many of these benefits will vanish. Same is the case with sorghum and also with soybean. Again, you see here the areas where we currently grow soybean, what we see a relatively small effect, but several other areas here may become suitable in time to come. Like this, we have done several studies practically in all crops, but what I would like to remind here that there are several uncertainties in many of these assessments, errors that we see in climate models, crop models, and data. Especially, there is no link with future irrigation water availability, no consideration of extremes, and above all, no consideration of future technological developments. Okay, let me quickly summarize what do we know today about the impacts on Indian agriculture. And I will largely talk about crops, although we know a lot about livestock and fish as well. What we see from our own experiment that as CO2 goes up, crop yields of most C3 crops is likely to increase by 10 to 20%. That's based on our own studies. At the same time, as temperature goes up by 1 degree Celsius, what we project that crop yields might decrease almost nothing to almost up to 7%. But at higher temperature, we expect higher losses. As a consequence, what we see in short term, by 2020, because of this mean changes in temperature and precipitation, most crops will show only a marginal decrease in yield. All will remain unaffected. But as time progresses, there will be considerable decrease. What we also have to appreciate that besides, while we talk about negative aspects, there are several opportunities that will become available. We see some improvements in yields of chickpea, and more so in crops such as winter maize, sorghum, and millets. And this area into this winter season is expanding already. What we also see less loss in potato, mustard, and vegetables in northwestern India, where currently we lose considerable yields due to frost. I'll give another example of opportunities that are becoming available. Now, this is about apple in India. What has been happening over time, if you look at this data of last 20, 25 years, apple yields in Himachal Pradesh has been coming down, and that's largely because chilling that is required is not really available. Temperatures have been going up. As a consequence, what we see, apple cultivation has shifted to upper elevations. The land vacated, farmers have started planting vegetables, and in fact, that is giving them higher price. So overall, the incomes have increased. So these are unusual opportunities which have become available to these farmers, and also to farmers who are in the upper regions, they've started producing apples. So it's opportunities such as this which really need to exploit further. Okay, now let me move on to the next point, which is about adaptation. Now, when we talk about adaptation, I think first it's very important for us to realize what are the goals for adaptation? Why are we wanting to adapt? To what extent we want to adapt? And I think what we really need to do here is to align them with national policies. Indian national policy is, for example, to maintain a growth rate of 4%, growth based on efficiency and conservation of resources, and growth that is inclusive and equitable. That's the broad policy guideline that we have for agriculture. So when it comes to goals of adaptation, if we try to align them, what we really need to do through adaptation is to produce more and diversified food that we need for future, and not to stabilize only. We have to produce more to meet the increasing demands. And also stabilizing production in climate stress seasons, raising input use efficiency to address the increasing competition that we have for land, water, capital, and labor from other sectors, and of course, greater focus on poor people to ensure equity and inclusive issues. So these are the broad goals of adaptation that we have to work on in the region. Let me now make the first proposition that how exactly we can enhance our adaptive capacity. The first point that we would like to highlight is there's huge scope still in the current technologies. And if we are able to raise our production using the current technology, we will be able to enhance our adaptive capacity. If we look at this slide, this is about wheat, how we have progressed over time. This is since 1960. This is the yield. We have been able to increase yields from almost 1 ton to close to now 3 tons per hectare. This is the biological potential, and the varieties have potential about 7.5 to 8 tons. Once you bring in issues of yield gap, what you see here, this is limited by climate, soil, and irrigation. So basically, this is the biophysical potential. That's sort of attainable yield that you can have. This, we have made tremendous progress by reducing this yield gap. If you see, this yield gap was more than 3 tons per hectare, which has been reduced to close to 1.5 tons. And what is exactly done here is, this is by improved crop management, risk management approaches, and so on and so forth. And what we really need to do is to further give more emphasis on this, because there's still a lot of gap that we need to exploit. And if we look at our demands in near future, they are still within the realms of this yield gap. Demand by 2020 is more or less within what is the current yield gap. But if we talk about more time in future, let's say beyond 2020, certainly this current technology, current genetic technology will not be enough, and we'll have to develop varieties with high yield potential. Okay, but agronomic adaptations, agronomic options, there are several of them, and that can help in short term. Let me explain this, a simple study of one of the crops. The impact, if we try to assess, this is for 2050 scenario, is about 20%. If we adapt simply by changing sowing date, we can alleviate this impact by about 5%. If we add to that change in variety, we can alleviate another 5%. And by including irrigation efficiency and fertilizer use efficiency, you're almost able to negate this whole impact of climate change. But what is very important, as I said in the beginning, for us, it is important not only to just nullify this negative impact, but also to produce more. And to do that, we need more inputs and better input use efficiency. Having said that, there's a cost involved. Now, this is an example of nitrogen use efficiency in rice. My colleague, Pathak, who just published this paper, has come up with a very interesting study. He evaluated several strategies which are used with dual benefits for adaptation and mitigation, and tried to work out what sort of cost is going to be for any of these strategies. So you see these green bars indicate for soil test-based response, plant test, leaf color chart, and so on and so forth. Except for zero tillage, all technologies showed a cost involved. And what you see here, the cost of urea, the cost of nitrogen at this moment is about 9 rupees per kg. So it's certainly not beneficial for farmers to adopt any of these technologies that we talk about, as long as the price of urea, the price of nitrogen remains much below many of these potentials that different technologies have. So while we talk about agronomic options, linking up with the cost-benefit analysis to understand what are the real options is extremely important. Let me at the same time point out that the government of India has started a national food security mission in 2007 in 301 districts, almost 50% of India, to raise production of 3 major crops by 20 million tons. And the approach that they're using is something very similar to what we discussed, using better seed, assured imports, farmers training, market links, demos, and so on and so forth. But what is also important for us to realize, and I think I've made this point a little earlier, but once again I'm trying to emphasize this, that climate change will limit the potential adaptation window in future. The type of window that we're talking about, using yield gaps to produce more, is a limited option, is an option for a limited time. And this slide shows that very well, that this has been the yield gap. Again, it's a slide of wheat. From 3.5 tons, it is about 2 tons in 2000. But as temperature goes up in future, what you see, the yield gaps themselves become smaller, largely because of the reduced potential yields of the current varieties. And as a consequence, this itself will not remain such a useful option in long term. Okay, now let me move on to the second point, which is about managing current and future short-term climatic risks. So I'm trying to use this terminology to differentiate between long-term mean scenarios that we talked about and the short-term climatic risks. And as we all know, climatic risks are very common in India. It's nothing unusual. 70% of our land is prone to drought, 12% to floods, 8% to cyclones, and every second or third year in some part of India, we have a major disaster. And almost 30 million people are affected annually. This chart shows the distribution of variety of these risks. And as we all understand, short periods of such risk can cause tremendous losses. For example, this is the case of sorghum. If rains fail in the first month, you lose almost everything. If they fail even for 15 days in this period, you again lose quite a bit, and the losses are again reasonably significant even for short periods in future. Okay, so what exactly we can do, and what are the proposed strategies? I'm going to propose here a 5-point strategy that we are following up with the Indian government to see how best we can use this to enhance our adaptive capacity. The first one is that we are strengthening our efforts to provide value-added weather services. And what I have written as a subnote here is what are the constraints in many of these services right now. Despite our best claims, what we still have is a reasonably weak weather infrastructure. We are not able to collect data at the farm level, and we certainly need to improve many of these data collection. We don't have enough data protocols, storage. Access remains a big issue. Whatever data is collected is often not available, and dissemination of that remains a weak point. But nevertheless, this is an extremely important area in which we are working together with the India Meteorology Department and many others to see how best this can be used for the benefit of farmers. The second one on which we are doing a lot of work is providing insurance for climate risk management. The type of risk that we're talking about, the type of frequency that we're talking about, providing this insurance is becoming quite a useful opportunity. But again, what are the limitations here? What we still don't have is a reasonable amount of scientific analysis and economically validated schemes. We are talking a lot about weather derivatives, but again, these schemes need to be developed. And of course, a lot of farmers, a lot of poor farmers are still not very aware of the type of schemes that we have. Third point on which we are emphasizing is facilitating community partnership in food, forage, and seed banks. Again, the limitation is technical know-how, capital costs, and reduced acceptance by community by itself if successive years happen to be risk-free. I think this is, again, a very important point, and we need to find a way to overcome many of this type of constraint. The fourth point, I think several people have talked about it, so I will not elaborate on it, that how best we can compensate farmers for environmental services. And the final point, again, sufficient discussion took place this morning about indigenous knowledge. There is a lot of knowledge available in climate risk areas such as ours, but what we really have to do is to find out whether these schemes are really valid anymore. In the new risk scenario that we're talking about, how useful are these experiences that we have had so far? Okay, before I conclude, I just want to make the last point, that policy responses have always been very robust. The Indian government, for example, has been responding to many of these climate risks time and again. This is an example of drought If you look at 1877, we had a major drought and there was a famine and millions of people died. Ever since, these red dots indicate deaths. Practically not many people have died, but what you see, several millions of people affected. Each dot is about 50 million people, and you see the number is increasing every year, not because of intensity of drought, but simply because the population is increased. But what is very important for us to realize, the response has been always there. And the response has been shifting from scarcity relief, it has moved to drought relief, to drought management, to water management, and more recently to knowledge management. So system is responding, system is developing schemes. That's another example of what we would like to have, is drought early warning system and response system. These are all there. All the elements that we talk about are there. There's a planning group, which is continuously monitoring rainfall, it's monitoring crops, it's monitoring reservoirs, issuing early warnings. It works at different scales and advises on what exactly should be done. But despite all this development which has taken place, what we still see, losses are still huge. Losses due to climatic risk, even due to drought, remain large. What are the key reasons? We try to analyze. There's still widespread poverty. We discussed this, and this shows here the type of poverty that we have, population less than $2 per day, very heavily concentrated Indo-Gangetic Plain, one of the target areas. Limited human capital, again, if you see here, especially in Indo-Gangetic Plains, literacy rates are quite low. But above all, what is very important, that despite all these schemes, poor governance, and the point that Dr. Joshi raised earlier, is one of the key reasons why we are not able to make much dent, which includes very limited stakeholder analysis. Normally, we're not talking much to farmers and to other stakeholders what exactly they need, and dissemination of knowledge. Our extension services have really gone down over time. Okay, I think I have to conclude now. Well, first point I would like to make and re-summarize what I said earlier, that there are large yield gaps, and this provides an opportunity to meet food demand. And in short term, there are several options available which we should be able to use to improve our adaptive capacity, but later we'll need better genotypes. Climate change provides new opportunities for growing crops in regions or in different time periods which were not considered suitable earlier. We need to understand them better and certainly need to manage them in long run. And final point, problems related to poverty, governance, institutions, and human capital limit agriculture growth today, and they can also possibly limit in future. Now, before I conclude, Bruce asked us to say our observations on the proposed mega program. I just have 3 points which I would like to highlight. I think what we need to do have a very clear identification of stakeholders. For whom are we doing this? I propose that we should be talking for 3 different levels of stakeholders. One, of course, farmers. Second is policy planners and industries, insurance, and carbon market. I think we need approaches. The questions that they ask are very different. We can't have one policy for all of them. Second point, which is based on a lot of interaction that we have in the region with parliamentarians, with policymakers, with farmers, and a variety of other stakeholders, which we have been discussing quite some time, that what exactly they want. What they are still interested in understanding vulnerabilities of the region. They would like to know at a disaggregated scale how vulnerable they are in different commodities. Also, they are not interested in agriculture alone. They are interested in overall enhancement of adaptive capacity. Agriculture is one of the sectors, of course, is one of the key sectors, but their interest is in overall development, not only agriculture alone. They're very keen about short-term action plans, and they would certainly like us not to talk about 2050 and beyond. And above all, they want integrated region-specific solutions. They don't want global solutions. They don't want national solutions if they're not national policymakers, but they want solutions on which they can act. And they don't want by themes. They certainly want a composite, integrated solution which is region-specific. Final point, I think we need new partnerships because the type of work that we are proposing to enhance adaptive capacity, we'll need to start talking to other actors in this field with whom we have not really earlier talked much. For example, science departments, ocean development, and so on and so forth, med departments. Development departments, for example, irrigation And disaster management agencies, I think we have not really given much thought to it, but they are also extremely useful actors. Industry, and finally, cooperatives. I think we have a lot of experience with cooperatives in India, and we should certainly be able to use their expertise. Thank you very much.